Hello everybody, we are Marco, Laura and Cesare and we are going to describe you a smart system called Internet of Beers. The aim of the proposed platform is to help home brewer in making beer. Here can be seen the hardware used. The Raspberry runs all the programs, simulates the smart plug and also works as a server. Being the system composed by two different phases, there are two different devices collecting data. For the fermentation phase, the Arduino Leonardo collects data related to room temperature and humidity by means of a DHT11 sensor. For the mesh phase, another Arduino collects data by means of a probe sensor. As can be seen from the plant, it is composed by different actors and it implements microservices architecture. The microservices approach is very important and useful since it makes our system modular and scalable. Actors interact with each other through MQTT protocol, passing information through the broker, and with the catalog by using REST. The function of the catalog is fundamental, because once connected, all the devices will automatically register themselves on it. The catalog is written in JSON and is structured in a way that every actor can easily find the needed information in order to run. In other words, every actor uses the four methods get, post, put and delete to exchange information with the catalog. It is also possible to add rooms and tanks to the catalog, only adding a new device. The system will do it by itself, registering the device ID, the status and the timestamp. The opposite happens when the device is disconnected. It will automatically delete itself from the catalog. This is the situation at the beginning. All the fields related to the devices are empty. This situation represents the catalog updated by the information sent by the devices. As can be seen, now all the devices fields are filled and the status is set to active.
I'm going to show you a useful platform called ThingSpeak. ThingSpeak allows the user to create different channels, and in our case we decided to create the channel of temperature, humidity, one for the heater status and the same for the humidifier. Also ThingSpeak allows us to do some post-process with the data we collected, and in particular we computed the average humidity, temperature and the instantaneous power and the electric consumption. In particular, the last two are really important for the user because they can make the user aware of the cost he is having. For all the channels that we are going to open, it's possible to see the trend of the data we collected in the time. And so in this way the user can have the possibility to monitor the situation every time he wants. The same we can see for the heater, that can be either on or off, and in particular we have a boolean value 0 and 1 that is going to show us if it is on or off. The instantaneous power is a post-process really important, and we computed it considering that our heater is composed by 4 different speeds, and for each speed we considered 300 watt of power. So the instantaneous power is computed taking into account the actual speed in which the heater is turned on. Instead, the electric consumption has been computed considering 300 watt of power for each level and the time a certain level is on. So basically it is computed the mean of the power of the particular level over the time it is turned on. Freeboard helps the user to visualize the trend of the data collected and computed in real time. In particular, for example, here there is the gauge of the humidity and the temperature, the indicator light for the heater status and the same for the dehumidifier, and the spark line for the heater and the dehumidifier. Also, it has been possible to export the post-process we computed on ThinkSpeak, and so the instantaneous power, electrical consumption, and so on. So in this way the user can access on Freeboard and have all the data together, and so in this way it is really comfortable. In absence of a real smart plug, its functioning is simulated by means of LED. In particular, there are 4 LED that represents the 4 power of the heater. The same happens for the dehumidifier, in which we can find the 2 LED that represents the state on-off. So by turning on one or more LED, we can understand the status of the heater and the dehumidifier.
Telegram is really useful for the user. The IoT beer bot has been created, and the user can select the proper command he wants to know how to get all the information anytime he needs. As you can see, Telegram gives data about temperature and humidity in real time. If we select the command humidity, you can see the actual humidity in the room. The status of heater underlying the current power status heater, and we can know if it is turned on or not. The status of the humidifier that can be turned on or off also. In the same way, is very useful during the cooking phase of the beer, and it implements the mesh control. The mesh control is implemented using an already open source project called RDBeer. This software allows the user to follow in a more comfortable way the cooking phases. In particular, we added to the open project a Wi-Fi module that allows it to expand in the IoT world, so it's possible to share information through internet. In our case, we are facing with Telegram. If the user set a temperature through LCD, in this case we put 27 degrees, and when this temperature will be reached, a message through Telegram will be received. Through mesh control command, I'm asking Telegram to advise me when the temperature selected will be reached. So we received this message. That means that our temperature, 27 degrees in this case, it's reached.
If you enjoyed the video, please leave a thumbs up.
Thank you for your attention.
See you to the next video!